In this lecture, we'll talk about the basics of how to measure interest rate risk. And you probably know this already, but just to make sure we understand what we mean by interest rate risk, essentially the idea is this, that when interest rates go up, the value of your fixed income securities go down. So from a risk management perspective, when we talk about interest rate risk, it's the risk that interest rates will go up, and hence the value of your fixed income securities will go down. So in terms of measuring interest rate risk, we are going to talk about a full valuation approach and a duration / convexity approach. On this slide, I just have some high-level points, and in subsequent slides we'll get into the details. But in terms of the basic points, when we talk about a full valuation approach, we need to know that it provides precise values, so that's an advantage. The full valuation approach can deal with both parallel as well as non-parallel shifts in the yield curve, so that's also an advantage. The disadvantage is that when you have a large complex portfolio, then using the full valuation approach can be time consuming, and potentially we might have to model many different scenarios. So if we are just talking about the full valuation approach for one simple straight bond, then this is not an issue. But for a complex portfolio with many different kinds of bonds, which might include bonds with embedded options, bonds with prepayment options, various kinds of amortizing bonds, then it can become a little tedious because we have to model many different scenarios. So that would go down as a disadvantage of the full valuation approach. The other major approach is called the duration / convexity approach. This method provides a nice approximation. In other words, it gives us approximate sensitivity of bond values to changes in yield to maturity. It is a simple measure of interest rate risk. In terms of disadvantages, this method assumes parallel shifts in the yield curve. So if we have a non-parallel shift in the yield curve, then that's a bit of an issue for this method. So now let's first talk about a full valuation approach. And the idea here is very simple. Let's say that you have a bond portfolio which consists of, let's say, bond A and bond B. So bond A and bond B. And I am basing this example on Exhibit 2 in the curriculum, which is on page 610 of the 2011 curriculum. But the idea is very simple. Let's say that at the current point in time, let's say that we have a certain yield in the market, and if given current yields, we have the value of bond A is equal to 100 and the value of bond B is equal to 120. So this is the, let's say, the total valuation of bond, market value of bond A and market value of bond B are under the current circumstances. Now let's say that we create now different scenarios. So in scenario 1, we say that interest rates go up by 50 basis points. So when interest rates go up by 50 basis points, what will happen to the value for bond A and bond B? The answer is, when interest rates go up by 50 basis points, obviously the values of bonds A and B will come down. So let's say that bond A comes down to 95, and let's say that bond B comes down to 115. So that means that the total value of our portfolio, which initially was 220, now when interest rates go up, the value of that portfolio is now down to 210. So we can simply say that with a 50 basis points rise in portfolio, the value of our portfolio comes down by 10, and obviously we can also calculate in percentage terms what this is happening. Note that these values are calculated based on, let's say, a precise revaluation of the bonds given the higher interest rates. We can then take a scenario 2 where we say that interest rates are now up by 100 basis points. Then again we would come up with the new values. Let's say when interest rates go up to 100 basis points, we have a new value for bond A, a new value for bond B, and I'm just making up numbers here. Let's say that bond B now comes down to approximately 90, and bond A comes down to 90, bond B comes down approximately to, let's say, 110. So now our bond value is down to, so this whole thing is now down to 200. So these are just made up numbers, but the point to illustrate here is, in the full valuation approach, we simply take give the interest rates a shock, which means that we assume that interest rates here have increased by 100 basis points, and then recalculate the value of all the bonds in the portfolio, add it up, get our portfolio value, and that essentially shows the impact of changes in interest rates or potential changes in interest rates. While this example was roughly based on what we have in the curriculum, but the numbers are different, and they are just a simplified form. But in terms of understanding the concept, what has been explained here is fundamentally what you need to know. Now we are going to talk about computing effective duration, and we saw this earlier in the reading on risks of investing in fixed income securities. But the formula that you see here is extremely important, and this formula is effective duration is V minus V plus over 2 V naught delta Y. You need to understand exactly what these terms mean and how to calculate them. So let's say that we are looking at the value or price. Sometimes the y-axis is called the price axis, sometimes it's called the value axis. So this is the price or value of your fixed income security, and let's say that the y-axis represents various yields to maturity, and we are basically plotting the price yield curve here. So let's say that for a given curve, our price yield looks like this, and assume that when we start, let's say that the yield is 8%, and at a yield of 8%, let's say that the bond is at par value, let's say, is 100. The way we calculate effective duration is, let's say that we increase interest rates by 50 basis points. So what that means, this delta y, so we say that delta y is equal to 50 basis points. 50 basis points, remember, is equal to 0.5%, which is equal to 0.005. So if, let's say, interest rates go up by 50 basis points, then our interest rate here is, or yield is 8.5%. At a yield of 8.5%, let's say that the bond price comes down to 99. So when we increase the interest rate, price comes down. What if the interest rate is decreased by 0.5%? Then we are here at 7.5%, and let's say that at this price, assume that the price at this yield of 7.5, let's say that the price of the bond becomes 102. Now in terms of plugging into the formula, the V minus means that we reduced the interest rate by delta y. This is the value when we reduce the interest rate by delta y, and in our example that's 102. So V minus is 102 minus V plus is the value of the bond when the interest rate is increased by delta y. In our example, that's the 99. So 102 minus 99 over 2 multiplied by V naught is the original value of the bond, which is 100, into delta y, where delta y is expressed as a decimal. So as a decimal, delta y is 0.005. So 0.005, you plug in or you solve this and you will get your effective duration is 3. So what we are effectively saying is that at this point where yield is 8% and the bond value is 100, the effective duration is 3, which means that a 1% change in yield will have approximately a 3% impact on the bond value. For you, it is extremely important to memorize this formula and understand what every term means in this formula and be able to plug in numbers and calculate effective duration. This is a very high probability question on the exam. So now let's talk about the concept of convexity and convexity adjustment. So continuing with the price versus yield curve for a bond, let's just plot this out again. So let's say that our price yield curve looks like this, and just continuing for a minute with the earlier example, let's say that we are talking about this point where the yield is equal to 8% and the price of the bond is equal to, let's say, 100, which is par value. And what we said earlier was that we calculated a duration is equal to 3. Let us make sure we understand what this implies. What the duration of 3 means that if our yield goes up by 1%, then our bond price will go down by 3%, and if the yield, so let's just draw that first. We essentially are looking at or describing the duration 3 as the slope at this point in time. So what we are saying is, if the yield goes up by 1%, so the yield goes from say 8 to 9, then what we are saying is, so yield goes from 8 to 9%, 1% increase in yield, and we say that according to the simplified duration measure, we say that the price will come down by, so the price comes down by 3%. And what if the yield goes down by 1%? So if we go from 8% down to 7%, then according to the simplified duration measure, then we again, looking at this straight line, we expect the price to go up by 3%. So when the yield comes down to 7%, according to the duration approximation, the price will go up by 3% to 103, and when the yield goes from 8 to 9%, we expect the price to come down by 3%. Now this simplified measure of duration ignores the fact that our curve is convex. And why do we call this convex? We call it convex because we assume that we are sitting here at the origin and looking at the curve. Looking at the curve from the origin, it appears, so looking from here, the curve appears convex. And essentially convexity is a measure of the curvature of this price yield curve. So the issue that we now face is convexity good or is convexity bad for an investor? And the way we can look at this is as follows. Actually, I will make a statement that convexity is good for the investor, and now I will explain why. Look at what happens when the interest rate goes up. If you are a fixed income investor, when interest rates go up, that is bad news. So look at what happens. When interest rates go up by say 1%, the value of the bond falls. So let's say initially the value of the bond was at 100, the value of the bond will fall from 100 down to this point A. And notice that this decrease in value from 100 down to A is less than 3%, because this line here represents a 3% decrease. So when bad things happen, i.e. interest rates going up, the bond value falls, which is what you expect, but the bond value falls by less than 3%. On the other hand, when good things happen, and if you are a fixed income investor, good things happening means interest rates going down. When interest rates go down by 1%, then notice that the bond price goes up by more than 3%. This point here represented a 3% increase, but the actual bond price is at B. And notice that point B is above 3. So when good things happen, the increase in price is more than 3%. When bad things happen, or equally bad things happen in terms of the yield going up by 1%, bond value falls but by less than 3%. So this benefit is because of the convexity of the price yield curve. So now the point is, how do we make an adjustment for that convexity? And to illustrate this point, I am going to use a different color now. So notice that in both situations, when interest rate goes up as well as when interest rate goes down, we need to add a certain amount to the value that we calculate using duration. So first look at the situation where interest rates go up. When interest rates go up, we have shown that the price according to this simple duration measure comes down by 3%, which is shown here. However, because of convexity, we need to add a certain amount. That certain amount is called a convexity adjustment. Similarly, when interest rates go down from 8% to 7%, the simple duration measure tells us that prices go up by 3%. But again, we need to add a certain adjustment called the convexity adjustment, shown by this blue line over here. So in both cases, when yield goes up and when yield goes down, we need to add a convexity adjustment to the simplified number that is given to us by the duration measure. So the next question then becomes, what is the convexity adjustment? And the answer is that convexity adjustment is calculated as the convexity of the curve times delta y squared. The convexity of this given curve will be given to you most probably on the exam, and let's say that the convexity of this curve is equal to 60. So 60 is just a measure of the convexity or curvature. We don't need to get deep into the interpretation of this, but if you have another curve that has a convexity of 70, that simply means that it is more curved than this one. If you have a convexity of 40, that would mean it is less curved than this one. In any case, to calculate the convexity adjustment, you simply say that it is equal to C times delta y squared. Now you need to be careful about the delta y. The delta y is written as a decimal. In this case, the delta y is the change in yield, which is 1%. The 1% written as a decimal is 0.01. So essentially this becomes 60 into 0.01 squared, and when you multiply this out, you will get 60. So you essentially, after doing these calculations, you get 60 into 0.0001, which is equal to 0.006, which is equal to 0.6%. So now what we are saying is that in both cases we make this convexity adjustment. So when the yield goes up by 1%, the price goes down by 3%, plus we are adding this convexity adjustment that we now know is 0.6%. So effectively we are then saying when we factor in the convexity of the curve, we then say that when the yield goes up by 1%, the price should go down by 3% and then make the convexity adjustment. So the overall impact will be down by 2.4%. So this makes more sense, because as we go from that starting point to point A, we now know that this is down by 2.4% and not down by 3%. Similarly, when the yield goes down, then the price goes up by 3% because of duration and another 0.6% because of convexity. So the overall impact will be up by 3.6%. And then given the bond value of 100, you can convert these percentages into actual bond values. But this should illustrate the point of convexity adjustment quite well. Another basic point is that even with the convexity adjustment, we are still talking about an approximation. So the way you can look at it is, the first level approximation is to simply use duration. When you add convexity adjustment, then your approximation is much better. But if you want the precise values, then you should use the full valuation method.